let me share something that might infuriate you. Last month, a woman walked into my shop ready to spend $8,000 on a transmission overhaul. Her Nissan was bucking, slipping between gears, and throwing codes like a broken slot machine. 3 different mechanics had told her the exact same thing. The transmission was done. Time to rebuild or replace. But here's what really happened. After just 15 minutes and $0 spent, I performed a simple electronic reset. The car drove out of my bay smoother than the day she bought it. No rebuild, no replacement, just a reset that cleared corrupted data from the transmission control module. This is not a one-time miracle. This is the reality behind 97% of modern vehicle issues. I've been turning wrenches for over 20 years, and it's absolutely clear the auto industry has changed more in the last decade than in the previous 50 combined. Your vehicle is no longer just a machine. It's a rolling supercomputer with more processing power than the spacecraft that landed on the moon. And just like your laptop or smartphone, sometimes it doesn't need new parts. It just needs to be shut down and restarted. Here's the uncomfortable truth that keeps me up at night. Most repair shops don't want you to understand this. I'm not saying every mechanic is dishonest, but the entire business model is built on parts and labor. A reset takes 5 minutes and generates no revenue. A sensor replacement takes an hour and bills out at $200. A transmission rebuild ties up the shop for 3 days and bills for thousands. Which one do you think gets recommended more often? That 97% figure isn't random. It comes from my own shop records combined with data from automotive engineers who've analyzed diagnostic reports from millions of vehicles. When you look at check engine lights, transmission complaints, rough idle, lousy fuel economy, sluggish acceleration, and weird electrical issues, the overwhelming majority trace back to corrupted data in electronic control modules, not failing hardware. These modules learn and adapt over time, storing information about how you drive, what kind of fuel you normally run, and even the climate and altitude where you live. When that data becomes corrupted, outdated, or conflicts with new inputs, the entire system can start acting up. Think about the last time your computer froze. Did you immediately assume the hard drive was toast? Did you call a tech to replace the motherboard? Of course not. You restarted it. The same logic applies to your vehicle, except most drivers have been trained to freak out at the first sign of trouble and rush to a shop where someone in a uniform tells them what's broken. Today, the curtain gets pulled back. I'm going to walk you through 7 professional-grade reset procedures that I personally use in my own shop every single day. These are not band-aid fixes or temporary hacks. They're legitimate diagnostic and repair methods that can permanently solve problems shops charge hundreds or thousands of dollars to fix. By the end of this video, you'll know more about your car's electronic systems than most people who work in quick lube bays. You'll understand when to reset, how to do it, and just as important, when a reset won't help so you don't waste time when there's a true mechanical failure. Before diving in, do me a favor. If you've ever been quoted some ridiculous repair price for something that turned out to be simple, hit that like button. And if you want more money-saving automotive intel that shops never advertise, subscribe to this channel. New videos drop every week with one goal: putting knowledge and control back in your hands where it belongs. Now let's break down why modern vehicles are so prone to electronic confusion and what that means for your wallet. The truth about modern cars. 30 years ago, when a car had a problem, it was almost always something physical. A worn belt, a leaking gasket, a clogged filter. Diagnosis was straightforward. You looked, listened, felt, and smelled. That approach is mostly obsolete now. A modern vehicle can have anywhere from 50 to 150 electronic control units depending on the make and model. These aren't simple chips. They are full-on computers running millions of lines of code, talking to each other over internal networks that look more like the internet than anything most people associate with a car. The engine control unit, or ECU, is the main brain. It watches data from dozens of sensors: oxygen sensors, mass airflow sensors, throttle position sensors, coolant temp sensors, NOx sensors, camshaft position sensors, and more. With that information, it constantly calculates the ideal amount of fuel to inject, the exact ignition timing, and how to adjust variable valve timing for the best mix of power and efficiency. It does this hundreds of times per second. The Transmission Control Module, or TCM, plays a similar role for your transmission. It monitors vehicle speed, throttle input, engine load, and fluid temperature to decide exactly when to shift and how firm each shift should be. In today's 8, 9, or 10-speed transmissions, the complexity is staggering. One miscalculation can cause harsh shifts, slipping, or a transmission that refuses to come out of second gear. On top of that, you've got the body control module, the ABS module, the airbag module, the climate control module, the infotainment system, and depending on the vehicle, modules for adaptive cruise control, lane keeping assist, blind spot monitoring, and more. All of these are constantly sharing information and making decisions based on what they learn. That's where the problems start. These modules use adaptive memory. They learn your driving style, your typical fuel quality, your usual environment, and adjust their strategies. This is often called adaptive learning, or a learning curve. For example, if you always drive gently, the TCM eventually programs softer shifts. If you tend to drive aggressively, it adapts to quicker, firmer shifts. If you live at higher elevation, the ECU will modify fuel delivery to compensate for the thinner air. When it's working properly, this is brilliant. But there's one big weakness. If a sensor starts feeding bad data, the module accepts it as truth and adapts around it. If the battery voltage dips or spikes, the module can log corrupted information. If you disconnect the battery the wrong way, modules can lose their reference points and have to start from scratch, often running poorly until they relearn. Even worse, if a module gets stuck using old data after you've actually repaired a real issue, it keeps compensating for a problem that no longer exists. Here's a real-world story. A customer brought me a Chevy Silverado that was guzzling fuel. His mileage had dropped from 18 mpg to 12 overnight. He had already replaced the air filter and spark plugs with no improvement. When I hooked up the scanner, the mass airflow sensor was reading correctly, but the fuel trims in the ECU were way off. The engine was getting far too much fuel. At some point in the past, the MAF sensor had been dirty and reported low airflow. The ECU responded by increasing fuel delivery. Even after the sensor was cleaned, the ECU kept using the old adaptation. A quick reset cleared the adaptive fuel trims, and after about 20 miles of driving, the truck was back at 18 mpg. No new parts, just bad data wiped out. That's the core idea you need to absorb. Many modern vehicle issues are software problems disguised as hardware failures. Shops are trained to test components, and when a reading looks borderline, they default to replacing the part. They rarely stop to ask whether the control module feeding or reading that sensor is operating on corrupted memory. Resetting doesn't make money because it prevents a parts sale, so it's not the first thing suggested. Voltage stability is another key factor. Your car's electrical system is designed to hold about 12.6 volts with the engine off and roughly 13.5 to 14.5 volts while running. But batteries age, alternators wear, connections corrode. When voltage swings too low or too high, modules can freak out. There are cases where a weak battery has triggered an airbag light, caused erratic shifting, and made the fuel gauge read wrong, all at the same time. Replace the battery, do a proper reset, and every one of those issues disappears. The bottom line: your car is extremely complex, but that complexity makes it vulnerable to simple electronic glitches that are easy to fix if you know what to do. The 7 reset methods you're about to learn are your toolkit for handling these electronic problems before you spend a cent on parts or labor. Each one targets different systems and different levels of severity. Learn these and you'll be ahead of 90% of drivers, and, frankly, ahead of a good number of mechanics. If this is clicking for you, drop a 1 in the comments. That tells me this is actually helping. And stick around, because there's something even more powerful coming later in the video. Method 1. Emergency battery reset. This is the oldest move in the book, but most people do it wrong. The idea is simple. You disconnect the battery, cutting power to all the vehicle's electronic modules, which forces them to clear adaptive memory and reboot. It's like doing a hard reset on your smartphone. But if you just pop the cable off and slap it back on 30 seconds later, you're only doing half the job. Here's how to do it the right way. First, make sure the vehicle is completely off. Turn the ignition off, pull the key, or press the stop button if you've got push-button start. Then find the battery. On most cars, it's under the hood, but on some models, it's in the trunk or under a seat. You'll see two terminals. One positive, usually with a red cap or red cable, and one negative, usually black. You're only going to disconnect the negative terminal. That's the ground, and removing it safely kills power to the entire vehicle. Use a wrench to loosen the nut on the negative cable clamp. You don't have to remove the nut all the way. Just loosen it enough that you can twist and pull the cable off the post. Once it's off, do not let that cable touch the positive terminal or bare metal on the car. Now, here's the step most people skip. After disconnecting the negative cable, press and hold the brake pedal for a full 30 seconds. That might sound odd, but it's essential. Modern vehicles use capacitors in many modules to store a little bit of charge even after the battery is unplugged. Pressing the brake pedal energizes circuits that help drain those capacitors. That way, the modules truly shut down instead of just going into sleep mode. Now, you wait. Patience actually matters here. At least 15 minutes is recommended, but for stubborn problems, 30 minutes, or even up to an hour, is better. During this downtime, adaptive memory is wiped. Fuel trims, idle corrections, shift strategies, throttle response maps. Everything goes back to factory defaults. After the wait, reconnect the negative cable and tighten it firmly. A loose battery connection can cause all kinds of strange electrical problems or even keep the car from starting. Once the cable is tight, turn the ignition to the on position without starting the engine. The dashboard will light up as modules wake up and run their self-checks. After about 10 seconds, start the engine. It may idle a little rough for the first minute or two. That's normal. The ECU is relearning idle control. Let it warm up. If you drive an automatic, the transmission controller is also relearning shift points, so the first few shifts might feel different. That usually smooths out quickly. What does this reset actually fix? Check engine lights caused by temporary sensor hiccups often clear. A rough idle often settles down as the ECU relearns the correct air-fuel strategy. Shifts usually improve as the TCM tosses the old logic and adapts to real-time conditions. Throttle response can sharpen if the stored throttle position or pedal data was corrupt. Here's a real situation. A Ford F-150 owner called me panicking. His truck suddenly dropped into limp mode on the highway, limiting him to about 35 mph. The dash was lit up like a Christmas tree. Traction control off, check engine light, transmission service warning. The dealer had already told him he needed a new throttle body and throttle position sensor, quoting $2,800 based on the codes. Before he signed off on that, he asked for my opinion. I went to his house and did exactly the battery reset procedure you just heard. The truck started right up with no warning lights. We drove it for about 20 minutes. Smooth acceleration, clean shifts, no issues. The real problem was a voltage spike from a failing alternator that had corrupted data in the ECU and TCM. The reset cleaned up the bad data, and replacing the alternator, about $320 installed, fixed the real cause. He walked away saving over $2,400, simply because he understood that modern problems often need modern solutions, not immediately throwing parts at the car. There is one downside to this method. You'll lose convenience settings. Your radio presets disappear. The clock resets. Seat memory may be erased. Some vehicles will require you to reinitialize the power windows, which will be covered later. But compare a few minutes of setting your favorite stations again to wasting hundreds or thousands of dollars on unnecessary repairs. It's a very easy trade-off. One important warning. If your vehicle has an advanced anti-theft system or requires a security code after battery disconnection, make sure you have that code before you start. Most modern vehicles in North America don't require this anymore, but some European and luxury models still do. Check your owner's manual or call the dealer to be sure. Method 2. Strategic fuse cycling. If the battery reset is a sledgehammer, fuse cycling is a scalpel. Instead of resetting the entire vehicle, you target a specific misbehaving module. This is ideal when you want to reboot just one system without dumping all your personal settings, or when a full battery reset didn't fix the issue. Every vehicle has at least one fuse box, and many have 2 or more. One is usually under the dash on the driver's side, another under the hood in the engine compartment. Inside, you'll find dozens of small fuses, each tied to a specific circuit. ECU, TCM, body control module, ABS, airbags, radio, power windows, and so on. The key is to figure out which fuse feeds the module you want to reset. You can usually find this in the owner's manual at the back or on the inside of the fuse box cover. If that's missing, a quick search with your year, make, and model plus fuse diagram usually pulls it up. Once you know the right fuse, here's how to proceed. Make sure the ignition is fully off. Open the fuse box and locate the correct fuse. They're usually labeled with abbreviations: ECU or PCM for the engine control module, TCM or trans for the transmission, BCM for body control, ABS for anti-lock brakes, etc. Use a fuse puller or a pair of needle nose pliers to pull the fuse straight out. Don't yank or twist hard. If it's stubborn, gently rock it side to side as you pull. Set the fuse aside and wait about 10 minutes. That gives the module time to power down completely and discharge. After 10 minutes, push the fuse back into the same spot firmly. Turn the ignition on and see if the issue is gone. Real example. A Dodge Charger owner came to me complaining that after a quick oil change, his transmission started banging into gear, especially from first to second. He thought the shop had overfilled the transmission or damaged something. My scan showed no codes, but the shifts were obviously harsh. What probably happened is that when the Quick Lube shop reset the oil life monitor, they cycled the ignition several times or briefly disconnected the battery. That confused the TCM and wiped some of its learned shift behavior. Rather than nuking all his settings with a battery reset, I pulled the TCM fuse, waited 10 minutes, reinstalled it, and took the car for a drive. Within 5 miles, it was shifting smoothly again. The TCM relearned the proper shift strategy from fresh data. Total time, 15 minutes. Cost, 0. Fuse cycling is also extremely effective for infotainment problems. Modern touchscreens freeze, lag, or stop responding all the time. Before wasting half a day at the dealer, pull the fuse for the infotainment system, wait 10 minutes, then reinstall it. That clears a frozen screen in roughly 8 out of 10 cases. The same goes for body control module issues. If your locks are acting weird, interior lights stay on, or random indicators flicker. A BCM reset via fuse pull often restores order. There was a Chevy Malibu I worked on where the interior lights stayed on after closing the doors and killed the battery overnight. The dealer wanted around $650 to replace the BCM. I pulled the BCM fuse for 10 minutes, reinstalled it, and the problem vanished permanently. The module just needed a reboot. One word of caution: you must be careful about which fuse you pull. Grab the wrong one and you might temporarily disable critical safety systems like airbags or ABS and trigger warning lights. Always double-check the diagram before removing anything. If you accidentally pull the wrong fuse, don't freak out. Just put it back and the system will usually come back online. Pro tip: snap a photo of the fuse box with your phone before you start. If anything gets mixed up or you forget where something goes, you'll have a reference. Many of the fuses look identical and it's easy to get confused. Strategic fuse cycling gives you surgical control. It lets you address the specific module causing trouble without hammering the whole car with a full reset. Because it's fast and simple, it's often the first move when a customer describes an intermittent electrical issue. If you're starting to see how powerful and money-saving these techniques are, hit that subscribe button. There are still 5 more methods to cover, and they get progressively more advanced. Method 3. Advanced Throttle Relearn Protocol. Modern throttles are electronic, not cable-driven. When you step on the gas, you're not physically pulling a cable connected to the throttle plate. You're sending an electrical signal to the ECU, which then commands a small motor to open the throttle body. This setup is called drive-by-wire or electronic throttle control. It gives the computer far more precise control and lets it adjust throttle response based on conditions. The trade-off is that the system leans heavily on learned data. Over time, carbon deposits build up in the throttle body. The throttle position sensor can drift slightly. The ECU's learned idle values can become inaccurate. The result can be sluggish acceleration, a sensitive or dead-feeling gas pedal, unstable idle, or even stalling. Many people assume the throttle body itself is bad and start shopping for a $300–600 replacement. In a lot of cases, a proper throttle relearn completely solves the issue for free. Here's how to do the standard procedure correctly. Make sure the vehicle is completely off. Put the key in, or have the key fob inside the car if you have push-button start. Turn the ignition to the on position so the dash lights come on, but do not start the engine. The gauge cluster should light up. Wait a full 3 seconds, then fully press the accelerator pedal to the floor and release it quickly. Repeat that 5 times in under 5 seconds. Think of it like a quick tap, 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 tap motion. After the 5th press, wait 7 seconds. Then press the accelerator pedal all the way down and hold it there for 15 seconds. During this time, you may notice the check engine light flashing or acting strangely. That's actually a good sign. It usually means the ECU has gone into relearn mode. After 15 seconds, release the pedal and wait another 7 seconds. Now, turn the ignition completely off. Then start the engine normally. Let the engine idle without touching the gas for at least 2 full minutes. The ECU is now relearning the correct idle speed and throttle position. You might see the RPMs move around a little. That's okay. After those 2 minutes, shut the engine off. Wait 10 seconds, then restart. Take the vehicle for a drive. Accelerate gently and vary your speeds. If you can, include some stop-and-go traffic. This helps the ECU rebuild its throttle response strategy under different loads. After about 10 miles of mixed driving, the system should be fully adapted. What kinds of issues does this fix? If the gas pedal felt like it had a delay or dead spot, where you pressed it and nothing happened for a split second, this often clears that up. If your idle was hunting, with RPMs rising and falling instead of staying steady, this usually smooths it out. If the vehicle hesitated on acceleration or felt like it was stumbling, a relearn can often get rid of that behavior. Here's a real case. A Toyota Tacoma owner reached out because his truck felt gutless. Every time he stepped on the gas, there was a noticeable lag before the engine responded, like the computer was half asleep. He'd already been to 2 shops. One wanted $150 to remove and clean the throttle body. The other said the throttle position sensor was failing and quoted $480 to replace the entire throttle body assembly. I had him do the throttle relearn procedure over the phone. It took maybe 5 minutes. He drove around the block a couple of times and called me back laughing. The lag was gone. The truck felt responsive and strong again. What happened? Over time, the ECU had adapted to a slightly dirty throttle body by changing how it controlled idle and throttle opening. Then he ran a fuel system cleaner that knocked some of the carbon loose and effectively cleaned the system. The ECU was still using old compensation data for a dirty throttle, so it made the truck feel lazy. The relearn cleared that outdated information and forced the ECU to adapt to the now clean throttle. Problem solved at 0 cost. This same procedure works extremely well right after a physical throttle body cleaning. If you've just cleaned it and now the engine idles badly or stalls, it's almost always because the ECU is still using old idle data meant for a restricted throttle. Run the relearn and it usually clears up immediately. There is a variation worth mentioning. Some manufacturers, Nissan and Infiniti in particular, use a slightly different sequence. Typically, you turn the ignition on, wait 3 seconds, then press and release the gas pedal 5 times in 5 seconds. Then you start the engine and let it idle for about 20 seconds, followed by holding the RPM at around 3000 for 20 seconds. Exact details can vary, so it's smart to look up the procedure for your specific model if the standard version doesn't seem to take. Throttle relearn is one of those behind-the-scenes tricks techs rely on constantly, but they rarely share with customers. Because once you know how to do it yourself, you're a lot less likely to pay someone to replace a throttle body or sensor that isn't actually bad. Method 4. The professional scanner method. Everything discussed so far can be done with little to no tools. If you want to seriously level up your diagnostic ability, though, an OBD2 scanner is a game changer. OBD2 means Onboard Diagnostics, version 2, and every vehicle sold in the US. Since 1996 has an OBD2 port, almost always under the dash on the driver's side. A basic OBD2 scanner, $20 to $50, can read and clear check engine light codes. A mid-range unit, $100 to $200, can talk to multiple modules, show live data, and run some reset functions. A full professional-grade scanner, $500 and up, can do almost everything, including advanced module programming. Most home mechanics don't need that level, but understanding what a modest scanner can do will save you a lot of money. Here's why it matters. When the check engine light comes on, the computer stores a diagnostic trouble code, DTC. That code points you toward the system or sensor that saw something out of range. For instance, P0420 is catalyst system efficiency below threshold, which usually points to a failing catalytic converter or an oxygen sensor issue. P0171 is System 2 Lean, Bank 1, commonly linked to a vacuum leak or a faulty MAF sensor. Without a scanner, you're in the dark. You see a light on your dash, but you don't know if it's a loose gas cap or a serious misfire. Shops know this and use it to their advantage. They hook up a scanner, read a code, and often jump straight to the most expensive associated repair. Sometimes they're right, sometimes they're not. Take a customer in California who was told she needed a new catalytic converter because her check engine light was on with a P0420 code. The estimate was $1,200 for the CAT and install. She called me for another opinion. I told her to buy a $30 scanner from Amazon, plug it in, and send me the exact code it gave. It was indeed P0420. Then I asked how the car was running. She said it felt totally normal. No loss of power, no strange smell, no rattles. I had her clear the code with the scanner and drive for a few days. If the light returned almost immediately, that would suggest a real catalytic converter issue. If it stayed off or only came back after a long time, it was more likely a temporary condition. She drove for 2 weeks. The light never returned. Most likely she had used low-quality fuel or driven in lots of stop-and-go traffic, which can temporarily make the oxygen sensors think the catalyst isn't doing its job. The ECU set the code and turned on the light, but the CAT itself was fine. Clearing the code and letting the system reevaluate fixed the problem. She saved $100 or $200 using a $30 tool and a phone call. A good scanner does more than read codes. Clearing codes is essentially a controlled reset for the ECU. You're telling it, forget this fault and start watching again from zero. Many one-time or environment-based problems never return after a clear. Mid-range scanners also let you see live data, which is incredibly powerful. You can watch oxygen sensor voltages, coolant temperature, throttle position, fuel trims, and a lot more in real time. If a sensor reading is obviously wrong, you found the likely culprit. If all readings look healthy but a code is set, you're probably dealing with a data glitch rather than a truly failed component. Some advanced scanners can also perform module-specific resets. You can reset the oil life monitor, clear transmission adaptive memory, or even run a throttle relearn directly from the tool's menu. That can be easier and faster than manual pedal and key procedures. If you're just getting started, A basic $30 scanner that reads and clears codes is more than enough. If you find yourself using it regularly and wanting more information, stepping up to a $150 model is worth it. Brands like Foxwell, Ansell, Blue Driver, and Autel have solid reputations at different price points. Avoid the rock-bottom no-name units. They can be inaccurate or unreliable. Keeping a scanner in your glove box is like having a basic medical degree for your car. You can figure out what's really going on, clear false alarms, and walk into a repair shop with facts instead of fear. And when someone tries to pitch you a $1,000 repair, you'll be able to tell if they're being honest or just taking advantage of your lack of information. If you're still watching at this point, drop a 2 in the comments. It shows you're serious about taking control of your vehicle maintenance instead of blindly trusting whatever a shop tells you. Method 5. Complete System Purge. This is the nuclear option. It's not something to use casually, but when a vehicle is acting completely insane and nothing else has worked, it can save you from a multi-thousand-dollar repair bill. A complete system purge combines aspects of the battery reset and fuse cycling, then pushes further by forcing every major control module to shut down completely and rebuild its adaptive memory from zero. When does this make sense? If the car is stuck in limp mode and won't come out. If the transmission is shifting erratically with no mechanical fault found. If the same check engine code keeps returning even after you've replaced the suspected part. If your idle is wildly unstable, or you've got multiple warning lights on with no obvious root cause. In short, when the car feels haunted and all the standard resets have failed. The process is more involved, so pay close attention. Start by turning the ignition completely off. Disconnect the negative battery cable exactly as described in Method 1. Then go to your fuse boxes and locate the fuses for the PCM or ECU, the TCM, and the BCM. Pull all three of those and set them aside. Now press and hold the brake pedal for a full 30 seconds to drain any remaining power. Here's what separates this from a basic reset. You now wait a full 30 minutes. Not 10, not 15, 30. That gives time for every capacitor in all those modules to fully discharge. Adaptive data is erased. Stored codes are cleared. It's the electronic equivalent of wiping a hard drive and reinstalling the operating system. After 30 minutes, reinstall the 3 fuses. Reconnect the negative battery terminal and tighten it firmly. Before starting the engine, turn the ignition to the on position and leave it there for about 30 seconds. This allows the modules to boot up and run their initial checks. Then start the engine and let it idle with all accessories off, no radio, no AC, no lights, for 5 minutes. RPM may wander a bit, and the engine may sound rough. That's normal. After 5 minutes, turn on the air conditioning and let it idle for another 5 minutes. This helps the ECU relearn idle targets under load. Once the full 10 minutes of idling is done, shut the engine off. Wait 10 seconds and restart. Let it idle for another 2 minutes, then shut it off again. At that point, the reset side is finished. Next is the relearn drive cycle. Take the car out and start on 25 to 35 miles residential streets. Drive gently with smooth starts and stops for about 5 miles. Then move to a main road where you can hold 45 to 55 mph for another 5 miles. Finally, if you can, get on the highway and run 60 to 70 miles for about 10 miles. The goal is to expose the system to a wide range of speeds and loads so the modules can rebuild their strategies. During those first few miles, expect the transmission to behave a little odd. Delayed shifts, abrupt shifts, that sort of thing. Don't panic. The TCM is essentially relearning from scratch. By around 20 miles, it should be noticeably smoother. Throttle response may also feel off at first, but should settle in quickly. For the next 50-100 miles, drive normally. You'll likely notice shifts, idle quality, and throttle response gradually improving as the system refines its learned data. Here's a real example. A Hyundai Sonata owner was told by a dealer that his transmission needed a full rebuild for $4,200. The car was stuck in limp mode and wouldn't shift past third gear. The dealer's diagnosis was based on multiple transmission fault codes. Before approving the work, he got in touch with me. I asked a few questions. Had any electrical work been done recently? Yes, a new alternator 2 weeks earlier. Was the battery disconnected during the job? Also, yes. That was the clue. When the alternator was replaced, the modules lost power but didn't properly reinitialize afterward. The TCM was running on incomplete data and defaulted to limp mode as a safety measure. I walked him through a full system purge over video chat. After the 30-minute wait and the relearn drive cycle, the car shifted cleanly through all gears and all warning lights were gone. The transmission itself had never been damaged. The controller just needed a complete reset and relearn. He saved over $4,000 with time and the right steps. This is not something you want to do every weekend. It wipes everything: radio presets, clock, seat memory, infotainment settings, all of it. You'll also have to reset auto window functions, which we'll get to in a moment. That said, when you're staring at a multi-thousand-dollar quote for something that might just be corrupted software, spending an hour on a complete purge is an easy choice. Just be aware that some European brands, BMW, Mercedes, VW, and others, may require a professional scan tool to finish off certain relearn routines after a purge. If you try this and the car still isn't right after 100 miles of driving, you may need a shop with the proper equipment to complete the process. Even then, you've usually ruled out a mechanical failure and narrowed the problem down to software, which is typically cheaper to handle. Method 6. Module-specific precision resets. While the nuclear option wipes everything, sometimes a more targeted approach is better. These module-focused resets go after the most common headaches drivers face without needing a complete purge. Here are 8 precision resets that fix roughly 80% of the most annoying modern car issues. First, the TPMS reset. After you inflate your tires to the correct pressure, the tire pressure monitoring light may stubbornly stay on. People end up paying tire shops $50 or more just to clear it. In many vehicles, you can do it yourself. Turn the ignition to on without starting the engine. Find the TPMS reset button, often under the steering column, inside the glove box, or near the driver's door jamb. Press and hold it until the TPMS light blinks 3 times, then release. Start the engine and drive for about 10 minutes at speeds over 30 mph. The system relearns the tire pressures and the warning light usually goes out. If there's no physical TPMS button, check the owner's manual. Some cars require you to use a menu option in the infotainment system to start the relearn. Second, the HVAC reset. If your climate control is sending air out of the wrong vents, randomly changing temperatures, or ignoring button presses, the blend door actuators may be out of sync. Many models let you reset the HVAC system by turning the ignition on, then pressing and holding the recirculation button and the rear defrost button at the same time for about 10 seconds. You'll often hear the system move through all vents as it recalibrates. This reset works on a lot of GM, Ford, and Chrysler products. Third, the steering angle sensor reset. After an alignment, battery swap, or steering repair, you might notice the steering wheel isn't quite centered, or the stability control light pops on. The steering angle sensor may just need to be recalibrated. Start the engine. Turn the wheel all the way left until it stops, then all the way right until it stops, then bring it back to dead center. Drive straight for about 100 to 200 yards. In many cars, that's enough for the sensor to recenter itself. A lot of modern vehicles do this automatically, but if the warning light stays on, the simple routine often clears it. Fourth, the transmission adaptive memory reset. If your transmission is shifting oddly, but you haven't gone through a full system purge, you can reset just the adaptive memory for the TCM. Turn the ignition to on without starting the engine. Fully depress the gas pedal and hold it to the floor for 10 seconds. While still holding the pedal down, turn the ignition off, then back on again. Keep holding the pedal for another 10 seconds, then release. Wait about 2 minutes, then start the engine. The TCM has now cleared its learned shift points and will begin relearning based on how you drive. This is especially helpful right after a transmission fluid change. Fifth, infotainment factory reset. Touch screens freezing, Bluetooth pairing issues, laggy menus, or glitchy navigation are incredibly common. Before booking a dealer appointment, go into the settings menu on the screen. Look for an option like Factory Reset, Master Reset, or Restore Defaults, and select it. Confirm the selection. The system will reboot and clear stored data. You will need to pair your phone again and re-enter navigation favorites, but this resolves about 90% of infotainment software bugs. If the screen is completely frozen and you can't access the menu, some systems allow a forced reboot by holding a combination of physical buttons, often power plus volume or seek, for about 10 seconds. Check your manual or a forum for the exact combo for your model. Sixth, auto window reset. After disconnecting the battery, power windows often lose their one-touch up-down function. You might see the window stop halfway, refuse to go all the way up, or roll back down as if something were blocking it. The fix is simple. Roll the window all the way down and, once it reaches the bottom, continue holding the switch for about 5 seconds. Then roll it all the way up and hold the switch for another 5 seconds after it fully closes. Repeat that 2 or 3 times. The window control module relearns the top and bottom limits and restores one-touch operation. You may have to repeat this for each window individually. Seventh, body control module, BCM, reset. Strange electrical gremlins, interior lights staying on, door locks cycling randomly, false warnings on the dash often point to a confused BCM. As covered earlier, find the BCM fuse using your diagram, pull it for about 10 minutes, then reinstall. Many odd behaviors disappear instantly. If they don't, some makes allow a BCM reset through a button sequence. For instance, certain Ford models require you to lock and unlock the doors with the key 3 times, then cycle the ignition on and off 3 times. The exact procedure varies, so checking owner forums for your specific car is extremely useful. Eighth, cruise control reset. If your cruise control suddenly stops engaging or acts unpredictably, it might just need to recalibrate. Start the engine and accelerate to around 40 mph. Turn on cruise control and let it hold speed for about 30 seconds, then turn it off. Repeat this cycle 3 times. In many vehicles, this is enough for the cruise module to reset itself. If that doesn't fix it, the problem could be as simple as a misadjusted brake light switch, but the reset is quick and worth trying first. These targeted resets allow you to fix specific problems quickly without resorting to drastic measures. They are fast, free, and surprisingly powerful. The real secret is simply knowing what to try for each symptom, and that knowledge is exactly what most shops rely on you not having.